Hello and welcome to today's webinar, where I will show you how to create and update openings in Revit MEP models. The Revit plugin conVoid is an advanced OpenBIM solution for MEP, structural engineers and architects. You can run the creation and coordination process with linked Revit files, IFC files and BCF files. I will record the webinar and upload it in the following days. If you have any questions, just use the chat and I will give the answers during the webinar. Let me introduce myself. My name is Pelle and I'm the founder and CEO of conClass. conClass is a technology company based in Norway. Our focus is on developing innovative and information-driven solutions in the field of BIM and machine learning. First, I will demonstrate how to create openings. After that, I will show you how to update openings. The next topic is how to modify and place openings manually. After that, I will explain how you can exclude elements from the conVoid process. Then I will show the parameter transfer and finally how to create drawings. The coordination and approval process will be demonstrated in the upcoming webinar for architects and structural engineers. Let's begin with a project example where I show you how to create openings based on linked architectural and structural models. Here's the Revit MEP project with a linked architectural and structural Revit model. As already mentioned, you can also use linked IFC models. First of all, you have to define the scope where to create openings. You can do so by opening a 3D view and activating and adjusting the section box. Now conVoid will create openings based on the elements in the active view. Another possibility is to use a floor or ceiling plan. Either you use the whole floor plan or you can minimize it with a crop view. Now I'm starting conVoid, and the first thing I have to do is to create a void filter. With a void filter you can filter all reference and host elements that should be used to create openings. Either you create a filter for MEP elements or a specific system type. Here I will select the levels to define my section scope. Means between the upper and lower level conVoid will create openings. Beneath I have to select my MEP projects. If I have more than one MEP project, I can also do a multi-selection. After that, I have to select all the MEP categories used to create openings. Here I have to select all the models with the host elements like walls, columns, beams, etc. So basically the architectural and structural model. Now you have to listen carefully. There's a difference between categories for horizontal and vertical voids. Horizontal voids are usually placed in walls and beams. This means you should just select the categories to create wall openings and openings for beams. Of course, you can also add more categories if needed. Furthermore, you have the opportunity to make a more specific selection of the elements based on the family type. This is really common if just structural host elements should be considered in the process. For vertical voids, select floors, roofs, stairs, and so on. Based on that selection, conVoid will run a clash detection. After conVoid detected clashes between reference and host elements, I can set the conditions. The first step I have to do is to select the level of the openings. I can choose between the host level, reference level, building story, and the specific level in my project. If you want to create horizontal openings and multiply stories, you should select the host or reference level. I show you the difference between these two levels in an example. Here we have a reference element in the center of the wall. Behind the element is the opening highlighted in green-blue. If I select the host level, the opening will adapt the upper and lower level of the wall. Based on that constraint, you will get the distance between the opening and the bottom and upper edge of the slab. If you select the reference level, the opening will adopt the level of the reference element. This means there is no constraint to an upper level of the wall and you have only the distance to the upper edge of the slab beneath. Beside that, you always get the distance to the project base point and the survey point. I always recommend using the host level for horizontal voids. The next step is to define the creation mode of the openings. There are 3 options to choose from. If you activate the opening mode, conVoid will always create a penetration that will run through the entire wall, even if the reference element is not intersecting the wall completely. If you activate recess, conVoid will only create such openings. The last mode is the auto mode. With that mode, conVoid will decide if the void should be calculated as a recess or opening. In addition to that, you can define an offset. This means the opening will get oversized on all edges. It's possible to modify the oversize with the feature void dimension in a later stage. The conVoid families are already pre-selected. If I renamed or duplicated the conVoid families, they will also be shown in the dropdown. Now I can use the parameter filter to filter the reference elements in more detail. For example, based on the system classification or category. That allows me to define different conditions for each added horizontal opening type. The green symbol gives me the information about how many openings possibly will be created. If you want to run the creation process with all reference elements, simply use a global parameter like face created. The same settings applies to vertical voids with one exception. If you are working with ceilings and floor plans, please select the level building story. If you are only working with floor plans, you can also use host level. Now I will jump into the settings. Here are multiply options which will affect the creation process. For now, I will keep the default settings to show you the changes if I modify the settings at a later stage. Finally, I'm starting the creation process. conVoid is now analyzing and placing the openings in the project. "65 openings have been created. Let's have a closer look. As you can see, all openings are shown in a 2D view. The same applies to the 3D view. The solids represent the openings. It would be possible to cut the openings with the host elements if they were not linked in my project. In my case, the architect and structural engineer have to adopt the families to create real openings. This can be done with conVoid, which I will demonstrate in the webinar for architects and structural engineers. So let's focus on the openings conVoid didn't create. There are 2 significant points to consider: the size of the opening and the angle to the host element. If an opening is smaller than the limit specified in the settings, no opening is created. If the angle of the reference element to the host element is greater than the limit specified in the settings, no opening is created either. I have a size limit of 80 mm, and the selected pipe has a diameter smaller than that. This also applies to the pipe and the beam. But here I have to check the angle to the host element because it looks like it has a greater angle than 45 degrees. Let's measure it in a 2D view. I'm just drawing a detail line really quick to represent the beam. Okay, the angle is 50 degrees, which means I have to set the limit at least at 50 degrees. Let's run conVoid again and change the settings. 10 millimeters for the size of the openings, and 51 degrees for the angle. conVoid is now creating and updating the openings. As you can see, conVoid will join openings automatically at the predefined distance, which you can also modify in the settings. Furthermore, we have two openings with a slope. Sometimes it's necessary to create openings with that, but it's not really common. Therefore, you can deactivate the calculation of openings with a slope. Another thing to mention is that conVoid will not create openings for reference and host elements that are parallel, like in this example. The reason for this is that conVoid assumes that this is a modeling inaccuracy. But there is also an option to allow conVoid to create such openings. The performance of conVoid depends on two major points. The first and most important one is the detail level of the element geometry. conVoid analyzed the dimension and location of the voids based on the reference geometry. If you are working with high detailed elements, conVoid needs a longer time to calculate the opening. This means you should keep the detail level as low as possible. conVoid will analyze the element geometry at the medium detail level. Check your high detailed families and modify them so that the medium level is not that detailed. This is often necessary if you are working with BIM objects from manufacturers. The second point is the number of views in your project. The more views are created in Revit project, the more time Revit needs to calculate the representation of the opening in the views. If you are working in big projects with over 2000 openings, I recommend using a separate Revit project which includes only coordination views. Let's modify the model to run the update process with conVoid. You can make modifications to your model at any time. conVoid will analyze all changes and will update the openings. So let me move a pipe and a dock. Next, I'm changing the dimension of the dock. And finally, I will do a major modification with the dock system. The only thing you have to do now is to restart conVoid. With the conVoid manager, I can add a color filter to highlight the status of the openings by a specific color. In the conVoid manager, all openings are listed in their status color. To identify what changes conVoid did, simply read the changelog. Now I'm adding the color filter to my active view. Make sure that the view template is set to none, otherwise conVoid can't add filters to your view. If you want to highlight the status in a different color, just select the color box in the new color. The color in the schedule and view will automatically be updated. You can also read the status and other information by selecting an opening. Here's an overview of all properties that will be updated if an opening is changed by conVoid. If the opening status is up to date, only the transfer parameter will be updated. but you can make modifications manually, which I will demonstrate next. Okay, let's talk about modifying and placing openings manually. You have multiple options to modify the openings after they have been created. First of all, I will focus on floor openings. Sometimes there are slanted walls where the floor opening are not parallel. But with a grid line, you can control the rotation of the floor openings. Simply draw a grid line next to the openings and start conVoid again. conVoid will now rotate the floor openings based on the closest grid line. Another option is to join openings manually. Select all openings which should be joined together and click Join Unjoin. You can unjoin the openings at any time. There is also the opportunity to change the shape of an opening by using the feature Circular Rectangular. The feature Void Dimension can be used to modify the oversize for selected voids. The first step is to create a void filter. In this example, I want to change the oversize of voids with a diameter less than 60 mm. Simply set the properties and filter the way you would create a schedule in Revit. The diameter represents the dimension of the reference element. The parameter total diameter is the dimension of the reference element plus the oversize. On the left side, you can define an oversize of the voids and a minimum size on the right side. If you hit apply, all listed openings will get oversize, and if you hit apply selection, just the selected ones. You can also set the oversize manually. Herefore, select an opening and set the new oversize with the left, right, top, bottom, back, or front parameters. These parameters can be changed at any time without conVoid recognizing any changes during the update process. You can still place your own openings at any time. This is often the case when there is no MEP element modeled yet. Simply select the conVoid family and place and adjust it as you need it. If an MEP element with similar dimensions pass through the opening, later on, conVoid automatically connects them. I will show you that in an example. Just let me create a new section view and the dock. And now I'm modifying the manually placed void. Okay, I will jump into the 3D view to run conVoid and update the openings based on the active view. As you can see in the changelog, conVoid connected the dock and the opening means the opening will be updated automatically the next time I will modify the dock. All my manually placed voids will also get the status manually. Based on that, I will have an overview of all manually placed openings in my project. Let's jump to the topic Exclude Elements. Sometimes it is necessary to exclude elements from the conVoid process. I will show you a few examples of situations where this may be necessary. If a pipe or another element creates an opening without wanting it, I can simply exclude the opening from the conVoid process by activating the parameter exclude from conVoid. This also applies to structural and architectural elements. In this case, the structural engineer excluded the wall from the process to avoid that the MEP engineer is placing openings there. If an MEP element intersects the wall, conVoid will recognize the excluded wall and not create an opening. I can also exclude the openings in case I want no changes made by conVoid. Let's run conVoid again. As you can see, the excluded opening didn't change. Furthermore, there has been no opening created in the excluded wall. And finally, the already existing opening got the status deleted because I excluded the pipe. This is a powerful way to get more control in your creation process. Another powerful tool of conVoid is the parameter transfer. In many projects, detailed documentation of the opening with all their information is needed. This includes, for example, the fire rating and the MEP system information. During the work with conVoid, you can transfer all kinds of parameters from the host and reference element to the openings. Here I have a fire rated wall. The parameter can easily be transferred to a selected parameter in the opening, in my case, the fire rating parameter. Another parameter I would like to transfer is the system abbreviation. The only thing I have to do is to set up the parameter transfer rules in conVoid. Here you can define the rules to transfer parameters from the reference element to the openings. Select the reference parameter and then the parameter in the opening. If more than one system intersects the opening, the separator is used. This means all parameter values will be combined. Down here, you can define the rules to transfer parameters from the host element to the opening. In my case, the fire rating of the wall. Let's check the parameters in the opening. Here it is, all parameter values have been transferred successfully. You can use or add your own parameters. I'm now adding a project parameter called system type opening for the category generic model. Now the parameter will also be listed in the drop-down menu. Okay, just let me transfer the system type information to the opening quickly. As you can see here, the separator combined all parameters. That's the way how to transfer parameters to the openings. The final topic is how to create drawings which include openings. We provide the tag family template that can show all relevant information of the opening in the drawing. You can modify the family or create your own one with the help of the shared parameter file, which we also provide. I will take a rectangular and circular void as an example. The tag shows various information about the opening type, the system abbreviation, the dimensions, the distance to the structural slab's lower edge, and the unique void ID. Here I have the distance to the slab above the opening. For circular voids, the distance from the axis to the slab is needed. In this case, just duplicate the current family and modify the type properties. If I change the family, you see that the distance to the slab is shown correctly in the tag. The conVoid family provides various distances from the opening top, center, and bottom edge. The distance to the project base point, survey point, and the upper and lower level. They can be shown in the tag by activating the parameters in the type properties. Now I'm switching to the floor plan to demonstrate the Smart Tag feature. Smart Tag can be used to tag elements of category and family type. Furthermore, Smart Tag tries to find the free spot for the tag in the plan to avoid overlapping tags and elements. Another point is the visibility of the openings in a floor or ceiling plan. Here I have an example of a floor opening placed in the stair, which is not visible in the view. Let me create the section view to explain it to you in more detail. By selecting the opening, you will see a blue vertical line which tells you where the symbol of the opening is visible. In this case, the cut plane in the floor plan does not intersect the vertical blue line of the opening. I'm switching back to the floor plan quickly to get the value of the cut plane. The offset of the cut plane is 1200 millimeters. I will draw that line in the section view to get a better understanding. The first step I have to do is to check the level constraint of the opening. In this case, the base and top level is level 2 finish floor. I will change the base level to level 1 finish floor and the top level to level P1. Now you will see the blue vertical line which intersects the detail line. The next step is to set the parameter value to 1200 millimeters. I will show you why I do this in a slide in a moment. If I switch back to the floor plan, the floor opening is visible now. Okay, let's have a closer look at how the floor opening works. The vertical blue solid lines represent the range where the solid symbol of the opening is shown in the plan. The dashed line represents the range where a dashed symbol of the opening is shown. If you take over the cut plane offset value to the parameters, you will get the correct symbolic in your plan. If you set the value to 0, the corresponding symbol is hidden in the view. Another example is an opening in the beam. The opening has the same level constraint at the beam since I use the host level setting. But in my active floor plan, the symbols are shown. And therefore, I'm changing the level of the opening. Here I will give the opening a new constraint to the edge to the slab beneath and the edge to the slab above. With the new level constraint, the opening is not visible in my active floor plan. This can also be done with multiple openings at once. Okay, now I have gone through all topics. As I mentioned at the beginning, the coordination and approval process of the openings will be explained in the upcoming webinar for architects and structural engineers. Thank you for your attention. I will answer the open questions now, but you can also contact us if you have any questions. You can also find more information about conVoid on our homepage and download the free trial version there.